Hello, you are welcome. My name is Dr. Kingsley. Welcome to my class today. I'm happy to have you back. Now, in my class today, I will be discussing calculation of relative atomic mass from isotopy. What does it mean? How to calculate the relative atomic mass of an element from isotopy. Now, what is relative atomic mass? Relative atomic mass of an element is the weighted average mass of that element relative to 1/12 the mass of a carbon-12 atom. Now, that is to say that relative atomic mass is an average mass. Now, before you talk about average, you should be talking about more than one, okay? More than one mass, okay? You cannot have average with one thing, one mass. So before you talk about average atomic mass, you know that we should be talking about what? More than one mass. So relative atomic mass is the average of what? Masses. Which masses? We are talking about what? The masses of isotopes of an element. Now, some elements have what we call isotopes. What are these isotopes? Okay, now isotopy actually is a phenomenon whereby some elements, okay, have different masses. Let me say, for example, an element which is chlorine having atomic number 17, because atomic number determine that this is chlorine, but one having the mass of 35 while the other one having the mass of 37. This occurrence is what we call isotopy. So chlorine 35 and chlorine 37, they are isotopes. Now, if they have one chlorine is having mass 35 while the other is having mass 37, we can take the average of these masses, okay, with reference to their abundances. Now, what I mean by abundance is what? How plentiful, okay, or plenteous, okay, that these chlorine isotopes occur on Earth. Now, we know that what? Chlorine 35 occurs on Earth more than chlorine 37. So we say that chlorine 35 is more abundant, okay, than chlorine 37. Chlorine 35 is about 75% in abundance. We take abundance of elements in percentage, while chlorine 37 is 25% in abundance. Now, that is to say that what? If we take the average masses of these isotopes, we'll be talking about what? Relative atomic mass. Now, the relative atomic mass of most elements is not a whole number, is a decimal. Now, if you are writing an exam, they ask you, why is the relative atomic mass of most elements not a whole number? The reason is because relative atomic mass is calculated from average of, okay, two or more masses. Now, there are some elements that their abundance is what? They have what? They have one isotope. Some elements have what? One isotope. Any element that have one isotope, we have a whole number atomic mass. But once the element have what? Isotopes, okay, that is 2 and above, okay, the relative atomic mass will surely be what? Okay, most times will be what? Will be a decimal, not a whole number. Now, having learned this, how do we calculate relative atomic mass? We have a formula we can use to calculate the relative atomic mass of elements. Now, the relative atomic mass of elements, I'm taking it to be what? RAM, RAM, relative atomic mass, can be given as summation n equals to 1 to n equals to I, then you have what? MI AI. Now, what do I mean by that? It simply means that the relative atomic mass of elements is a summation depending on the number of what? Abundances, or the number of isotopes, sorry, depending on the number of what? Isotopes. But is a what? A summation of products. What is the product? The product is what? Mass of one of the isotope multiplied by the abundance of that what? Isotope. But everything must be taken over what? Over 100%. Now, that simply means that relative atomic mass of elements, if I should open this thing up, what it means is what? It means mass of what? The first isotope multiplied by the abundance of that isotope plus mass of the second isotope multiplied by the abundance of that second isotope plus mass of the third isotope multiplied by the abundance of the third isotope, and so on and so forth. Everything divided by what? By 100. So this is the formula that we can use to calculate relative atomic mass of elements. So by this, we are going to take what? Example on how to make calculation on relative atomic mass. Okay, let us take this question. Now, this question is coming from JAMB. It's a JAMB question, JAMB 1980 question 25. It says, given the mean atomic mass, mean here means what? Average. The average or mean atomic mass of chlorine prepared in the laboratory to be 35.5. So the atomic mass, the mean or average atomic mass, the solution here, let us be bringing our parameters one by one. Now, the mean atomic mass is given to be 35.5. Remember, mean atomic mass is same thing as what? Relative atomic mass. Okay, is given to us to be 35.5. And assuming that chlorine contains two isotopes of masses, so there are two isotopes. Those two isotopes, isotope of masses 35 and 37. Okay, which means we are given the two masses of the what? Of the isotope. Mass 1 is 35, while mass 2 is given to be what? 37. Okay, if mass 1 is equals to 35, then mass 2 is equals to what? Is equals to 37. They are now saying we should find the what? We should find the what? The percentage composition of what? The isotope of mass number 35. Percentage composition here means the abundance. Remember, in relative atomic mass calculation, the abundance is given in percentage. So we don't know the abundance of this is not given to us in this question. We don't know the abundance of this mass also is not given to us. But the one required from us is for us to calculate the abundance of what? Of 35. Now, what do we do? Let us say the abundance of what? The 35. Let us take it to be what? To be y. Now, if the abundance of what? Of 35. Remember the mass, M1 is 35. The abundance A1 of that mass 35. Let's take it to be y. Then the mass that is 37. The abundance, which is A2, should be, if the abundance of the first one is what? Is y, then the abundance of the second one should be 100 minus y. The reason is because the summation of all the abundances must sum up to 100%. That is why if this one is y, okay, how to get the other one should not be what? 100, okay, minus y. Just like assuming if y, for example, is 60, then the other one should be what? 100 minus 60, which is 40, because 60 plus 40 will give us 100. Now, how do we now go on with this, okay, calculation? Now, what I'll do is this. I'll put down the formulas, then we'll calculate. Remember, relative atomic mass is equals to what? Mass 1 abundant 1 plus mass 2 abundant 2. Okay? Because there are only what? 2 isotopes. We'll not continue with mass 3 abundance 3 because there are only 2 isotopes. So mass 1 abundant 1 mass 2, abundance 2, okay, divided by what? By 100. That means that 35.5, which is the what? The relative atomic mass that is given, will be equals to what? The first mass, which is what? Which is 35. Multiplied by its abundance, we took it to be y. Okay, then plus mass 2, which is what? 37. Then multiply by its abundance, which is 100 minus y. So we have 100 minus y. Then everything divided by what? By 100. So we do this, multiply by this, that will give us 3, 5, okay, 0. That is 100 multiplied by 35.5 will be equals to, this multiplied by this will give us 35y. Then open this bracket plus, okay, 37 multiplied by 100 will be 700. Okay, minus 37 multiplied by y will give us 37y. Okay, now want to collect like terms. Okay, we'll be having 35, that is 3550. Take the one without a y to this side, will become minus 3700, will become equals to 35y here. Okay, then minus what? Minus 30. So if we do this minus this, it will give us minus 150, will be equals to 35y minus 37y will give us minus 2y. Therefore, it simply means that y will be equals to, make y the subject, minus 150 over minus 2. So y will be equals to 75%. That is to say that the one with the abundance of 35, okay, is 75%. So let us take question 2. Now question 2 is coming from JAMB past question, that is UTME 1987 question 10. It says an element Z contains 90% of, okay, Z, atomic number 8, mass number 16, and 10% of Z, that is a mass number 18. Its relative atomic mass is dash. So we are required to find the relative atomic mass of Z. We know that what? Relative atomic mass, okay, of an element is what? Summation of n equals to 1 to n equals to I, okay, abundant I, okay, mass I, okay, abundant I. Now that means that RAM becomes equals to, okay, mass 1, okay, abundance 1 plus mass 2, abundant 2 over 100, okay, 100, because we have only 2, okay, abundances. That means the relative atomic mass, okay, of the element will be, the first mass is 16, okay, we have 16 multiplied by its abundance. Abundance is in percentage, that is 90, okay, plus mass 2, which is what? Mass 2 is 18, multiplied by the abundance 2, which is what? 10. So everything divided by 100. So the relative atomic mass will be equals to 16 times 90. That will give us 1440 plus 180. That is 18 times 10. Everything divided by 100. Now we add these two together. The relative atomic mass, okay, will become equals to this plus 2 will give us, okay, 1620, okay, divided by 100. So the relative atomic mass of Z is equals to 16.2 as the answer. So come to question 3, okay, question 3. Now please, if you are still following up the class till now, do good to hit the subscribe button, like and share the video. Thank you. Now as we go on, question 3 says the atomic masses of the two stable isotopes of boron, okay, Okay, this is a boron. That is a B-O-R-O-N. Okay, or boron. Okay, that is boron 10 and boron 11 are this and this. Okay, the atomic masses are this and this. So you see that this is mass 1 and this is what? This is mass 2 respectively. Their fractional abundance are this and this. Remember, the abundance here is given to be this and this. So this is abundant 1 and this is abundant what? 2. Remember, this is fractional abundance because it's not given in percentage. Now, having gotten this, remember the masses we'll be using is this mass and this mass. Assuming this is not provided, we would have used this approximate what? Mass 10 and 11. But since they provided the what? The actual complete mass without approximation, so we use this and this. Now, if we want to do this, you remember that what? That relative atomic mass, which is a RAM, okay, is equals to mass 1 abundant 1 plus mass 2 abundant 2 over 100. Okay, why are we dividing by 100? Is in percentage. Anytime the abundance is in percentage, we divide by 100. But if you look at this, you find out that the abundance is not in what? Is not in percentage. So there is no need of dividing by 100 again. So our relative atomic mass in this case will be mass 1 multiplied by the what? The fractional abundance plus mass 2 multiplied by fractional abundant 2. Remember, this is a fractional abundant 1 and this is what? Fractional, okay, abundant 2. So it's in fraction. No need to do divided by 100. We will use this. So having taken that, our RAM will be equals to mass 1, which is okay, 10.013 multiplied by its fractional abundant, which is 0.1978, then plus, okay, you have mass 2, which is this, that is 10, okay, which is this 11.009 multiplied by the fractional abundance, which is this, that is 0.8022. Then you are not dividing by 100 because the abundance is in fraction, not in percentage. Assuming it's in percentage, you would have divided by 100. Now in this case, our RAM, okay, will be equals to, you multiply this by this, you multiply by this. When you add two of them together, okay, I think by calculator. All right, I don't know if I'm having calculator here. Okay, all right, so by calculator we are having 10.8 as the answer. So thank you very much. Do good to subscribe to my channel. Thank you.